And inequality is used whenever we're comparing things that are unequal. So I wrote 10 is less than 25. In symbols, that would be 10, the less than symbol, and 25. So that's clearly a true statement. And then also we have 1.5 is greater than -7, and this is the symbol we would use for that. So both of these things are true statements. Now, you can always rewrite these and put 25 on one side, 10 on the other, and we're saying the same thing if you state 25 is greater than 10. Likewise, if we have -7 and 1.5, we could use less than to say -7 is less than 1.5. Now, moving from just some numbers to introducing a variable, in example 1, I would like to graph x is less than 4 on a number line. That means write all numbers that make that expression a true statement. And we'll do the same thing for this one over here, which is x is bigger than or equal to -5. But starting with this, x is less than 4. Maybe just jotting down a few numbers that make this true. 0, that works. You can highlight it on a number line. 1 works, so does 2 and 3. Those are all okay. But you can't use 4, so I'm going to draw an open circle here. So 4 less than 4 is not a true statement, but you can use every number that goes right up until you get to 4. So on a number line, x less than 4 means everything that is to the left of 4, not including it. So any spot you pick, like -1, -2, -3, all make this a true statement. If we compare that to x is greater than or equal to 5, -5 that is, so again, I'll draw a number line, and just think about all the numbers that make that true. You could start with anything. Again, I could use 0. 0 definitely makes this a true statement. So does -1, -2, -3, -4, and -5 as well. -5 is equal to -5, so it's certainly greater than or equal to it. So I'll put a closed circle here, and then just note that things to the right of this value make this inequality a true statement. So that's everything going in this direction. This is what it means to be greater than or equal to -5. We're starting at -5, including it, but we're moving to the right. So in example 2, now we have something a little bit more complicated. We have 2x plus 3 is greater than or equal to -7. The goal is to, on a number line, write down all of the numbers that make this thing a true statement. And what's difficult about it is it's not just x on one side, but it's 2x plus 3. So we can't just go to -7 and say we're bigger than it or less than it or something like that. We have to do a little bit of work before we can start graphing the solution on a number line. And the good news is we can treat this a lot like solving an equation. So just to copy this down again, we have 2x plus 3 is bigger than or equal to -7. I basically want to solve this thing for x. So looking at the 2x and the 3, well, I want to get x by itself eventually, which means the 3 has got to go away. So what I'm going to do is subtract 3 from both sides. And this is where we have to be just a little bit careful. If this side is bigger than or equal to this side, and I decrease them both by the same amount, the result has to be greater than as well. So by that I mean, on the left, we have 2x, the 3's cancel. On the right, we have -10, but we still have greater than or equal to. I dropped both sides by the same amount. Okay, second thing would be all right, I want to get x by itself. To get rid of this 2, I can divide the left by 2 and the right by 2. I know on the left we get x. On the right we get -5. Okay, and I still think that it's greater than or equal to. I mean, certainly if this side is bigger than this side, and you cut them both in half, the result still has to be greater than. But this is perfect. These statements are all equivalent. meaning to graph the solution on a number line, I can just use this portion here. X is bigger than or equal to -5, but we already know what that means. We can draw a number line. I can mark where -5 is, maybe that's right here. And bigger than it means I'm taking all of these values. So this is what it means to solve a linear inequality. Start with the expression, solve it for x, and then decide which side of 5, in this case, sorry, -5, that we're working on. For the last example, I want to introduce the only thing that could go wrong in this process of solving a linear inequality. If you ever multiply or divide both sides by a negative number, it's going to switch the direction of the inequality, meaning it'll go from either less than to greater than, or greater than to less than. To see why this is true, I just wrote a simple example down here. We have -4 is less than 8. I mean, that's clearly a true statement. Now, if I divide both sides by -1, the result on the left would be a +5. The result on the right is a -8. But less than is not a true statement anymore. I mean, 5 is not less than -8. In fact, it's greater than. So this switched directions. So this is the only thing to watch out for. If you multiply or divide both sides by a negative number, you have to switch the direction of the inequality. So let's see if that happens in example 3. Okay, my goal is to get all of the x's to one side so I can simply state what the answer is. Okay, I'm seeing there's a fraction, there's a denominator of 3. I'm going to multiply both sides of this inequality by 3, a positive number. I know that's not going to do anything to the direction of the inequality, but it will cancel the fractions. So let's write that out. On the left, I have 3 over 1, and that's multiplied to 2/3 x minus, okay, I'm going to multiply, I'll just write it as 3 times 1. I still have less than, and on the right, I have 3 times x minus 3 times 4. So the reason for doing this is I'm canceling the denominator of 3, and I'm left with 2x minus 3 is less than 3x minus 12. So now if I want to solve this thing for x, I think what I'm going to do is, there's a couple of different approaches you could take, but I think I'm going to subtract 3x from both sides of this. And when I do that, on the left, I have -x minus 3 is less than, and then I get -12. Okay, I then have to, I'm going to add 3 to both sides. Running out of a little bit of room here, but I get -x on the left, still is less than, and on the right, I have -9. And we're very close to being done. I mean, basically, I just have to get x by itself, and there's a -1 in front of it. So what I'm going to do on both sides is divide by -1. It's perfect because on the left, the negatives cancel, giving me just x. And the negatives cancel on the right too to give us 9. But this switches. It's now x is greater than 9 instead of less than. So if you look at a number line, drawing this out, you're starting at 9. You're not including it, but you're greater than it means you're going to the right. And that's the answer to this example.